Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 9, Section 4, Pythagorean theorem. And today I just wanted to show it's a visual proof of why Pythagorean theorem works, showing you that yes, this a squared plus b squared equals c squared formula for right triangles does in fact work. A squared plus b squared does actually equal c squared. So what I would like to point out is these two squares here in this picture are the same exact size. Inside both of these squares we have 4 right triangles in each of them. Okay, and so inside each square, these 2 right triangles are the same right triangles as these 2. These 2 right triangles here are the same 2 right triangles as these 2. Okay, and so the whole purpose of this is to show you that a squared plus b squared equals c squared. And this triangle, the white area in the middle, formed by these right triangles, actually represents c squared. Okay. This triangle will represents a squared, and this represents b squared. Now, if you're looking at a right triangle, you have a, b, and c. So the formula what it's saying is if I square this leg and I add it to the square of this leg here, because these are called the legs of the triangle, okay? And I add them together. So if I square a and b and then add them together, it will be equal to the length of c squared, or in other words, the hypotenuse squared. Now, what this picture is showing is it's actually showing a squared, b squared, and c squared in its visual form, because when we talk about squaring something, okay, so for example, the reason why we call it squared instead of to the second power, because you can call this 5 to the second power, but the reason why we call it squared is because when you write out 5 squared, or 5 to the second power, you write out 5 times 5. Now, if you're going to find the area of a square with sides of 5, you actually, to find the area, would have to do 5 times 5. Or if you wanted to find the area of a square that had sides of 6, you would do 6 times 6. Or sides of 8, you would do 8 times 8. Or if you want to do sides of 230, you'd do 230 times 230. So what they're showing you here is with the long side of the right triangles, okay, or B, okay, I've created that square that we're talking about. Okay, this has a length of b, this has a length of b, so the area of this square is b squared. Okay. Over here, this little white space, or the little white square over here, is made up of sides of a and a. Okay. So the area of this little white square would be a squared, or a times a. Okay. In this identical square with identical right triangles, okay, what we've done is we've created a square, okay, using side C, or the hypotenuse of each right triangle. So since each side of the square has a length of C, to find the area of that square, you would do c times c and get c squared. These two squares are equal. The white space here, represented by a squared and b squared, is equal to the white space here, represented by c squared. How do we know this? Well, if both of these squares are equal, and all 4 triangles in each square are also equal, then that means the white space left over should be equal. Okay? This white space shouldn't be more or less than the white space in this square, because basically all we did was we took these triangles and move them around inside the square to create a different shape with the white space. But the amount of white space that is there should be the same because the amount of space these triangles are taking up has not changed. So all that has changed is the shape of the space that the triangles aren't taking up. Or in other words, the shape of the white space has changed because we move the triangles around. Okay. So again, this little square is made up of the A side, or the smaller leg, of the right triangles. This larger square here is made up of sides of B, okay, the long leg of the right triangles. So the area of the little one would be A times A, or A squared. Area of the larger one would be B times B, or B squared. And the area of the really big square over here is made up of the hypotenuse. The sides are the length of the hypotenuse, or C. So C times C would get us C squared. Okay? And again, these four triangles here are the same four triangles that are over here. So the amount of space these four triangles are taking up in this square is the same amount of space they're taking up in this square. Okay? So the amount of white space left in this square is equal to the amount of white space left in this square. Okay? Because these squares are the same size. So this is a visual proof showing you that A squared plus B squared equals C squared. Because here you can see that the space represented by A squared and B squared is the same size as a space represented by C squared. They're equal. Okay? So that would be the proof as to why this works. That shows you that yes, this does in fact work. I think it's a nice visual proof. It's a different one than what I was shown growing up that I feel makes more sense to me. So hopefully that helped clarify a few things for you. If you were curious, where this formula came from, why it works, this hopefully helps kind of settle you a little bit and makes you a little bit more confident that this isn't just something that is being thrown at you and you're being forced to believe it works, not because you know it works, but because someone told you it works. I don't like my students to go through this course being told things work. I want them to know things work when I show them something like the Pythagorean theorem. So in the next video, we'll be showing you different ways you can use the Pythagorean theorem.